Hi there, today we are going to talk about perspective, and here we got a task where we need to create perspective image of a house. So here you see a description on what sizes the house has to have, yeah. And here we are going to deal with scale because we can't use 8.5 meters when we are on paper. But it's actually not a point of the task. So here we got two lines, horizon, and the image projection or image surface, yeah. That image surface goes through the building. In other words, the building intersects with this image surface. Also, we got a position of a viewer, and we got the position of light and its vanishing point. So all that is quite enough to build a perspective image. And yeah, let's talk about how to do that in general, then we are going to dive into the details. So let me just delete that previous things. Good. Okay, so we got a few layers, and this will be for building rays that goes from viewers' eyes. So we are going to start with the surface of the building, with the wall that goes through the surface of projection, A line. Why here? Because only where the building or another object intersects with this surface, only in these places we are going to have real sizes of objects. In all other cases, here or there, the chimney, they are going to be distorted. What is in front of the surface will be bigger. What is beyond it will be smaller. Yeah, only where it intersects with the line, here we are going to have real sizes. Okay, that's why we are starting here, because we got only one point, let's say one of main points of the building that intersects with this line. Okay, so let me create this one will be here, two lines like that, yeah. This line goes through the image surface in this point. This one should be extended like that. Then I'm going to show you where the points are. So we always need to find points that are laying on the line that represents the image of the image surface. Okay, so then we are going to dive into another layer, and this layer will be only for creating vertical lines. In this kind of perspective, vertical lines, for example, line that goes from the bottom of the building to the edge of the roof, such lines will be vertical without any distortions. In some kinds of perspective you can find that they are oblique like that, but not in this kind of perspective. So this layer, or this color, let's say so, will be devoted only for such lines. So we found the positions of these lines, this one and that one, but we are still not in the know about the height of them, right? And this point can help us because here we know that the edge of the ridge of the roof is 8.5 meters from the bottom. Okay, so here we got, we need to build vanishing points, of course. So how we can do that? Let me create another color. So to be able to build such vanishing points, we only need to know the position of the viewer, and we should have the orthogonal plan of the building or another object that you are going to work with. Yeah. So let's say this line or this direction. We need to create a line that is parallel to this line, and it starts at the position of the viewer. So let's create a line. Let me change the color because I don't understand which line I'm touching. Yeah. So this line is parallel to the edge of the frontal wall, right? And we need to extend it till it penetrates the image surface, like that. So here you are going to have this point where the line goes through the image surface. After that, you should use a reference line and find its intersection with the horizon. So here will be a vanishing point for this direction. Another little comment. Here, and actually in the majority of exercises, you are going to have right angle between the lines in the plane. So this situation that I'm describing works only for such lines. If the angle is different, if it's sharp, for example, this way won't work. So let me then go back to here. Now we are going to create another line that goes from the same point C. We need to extend it till it goes to the image surface, and then using the reference line, you just find where it intersects with the horizon. Good. So we can name them if we like. Yeah, let's do that. Let me just name them 1 and 2. This will be 2 because normally we read from here to there, but it's completely up to you. And you can leave them unnamed as well. Okay, so knowing where the vanishing points are, let's create now something like that. So this point, this line, if you like, goes from the base of the balcony to the peak of the roof, right? And we know that the edge of the roof is raised 8.5 meters above the ground. So from this point to the top will be 8.5 meters. Here we are using scale. So instead of 8,500 mils, I'm going to use 170. So let's calculate what the scale we are using. I guess it's 1 to 50. So we only need to divide the original size by the new one. Yeah, and it's 50. So the scale here, 1 to 50. But of course, here you can see I'm using a program and the drawing space is unlimited. You should always find what scale is good for you. If, for example, you are drawing on paper. All right, so from the base to the end of the line, 170 mils, and that stands for 8.5 meters in my case. Let me change the color. So now, since I want to find the base of this line and that line, I need to use this vanishing point, because this side and that vanishing point, they are corresponding. So the first line that goes through the vanishing point will go also through the intersection of the building and the image surface, like that. We can create another line. It doesn't make much sense because here we got a kind of triangle, yeah? But it's also not bad. So the sense of this is just to approximate the building to a box. Yeah, so thus we got understanding of where the upper edge of the box is. So, but the floor is more interesting for us. So we found where this point is on the surface of the image here, yeah? So we need to find its intersection with the green line that goes through the base. Like that. The same for this situation. Like that. So we know now where the edge, where the face of this thing is, if it was a square. Actually not square, but rectangle, yeah? Let's add the slopes here, so it's more, you know, recognizable as a part of the building. Okay, so let's see what is written here in the text. So height of the floors equals to 3 meters. Here is not said anything about how many floors are in the building, but I guess only 2. So 2 gives us 6 meters on this side, and in this case the building looks fine. Okay, so let's create here a line equals to 6 meters in scale 1 to 50. It will be 120 mils, like that. So this line is used, as you can see, for measuring real sizes. Alright, then I'm going to pass a line through this point, like that, and I can say where the point of the triangular roof are. Here and here. Great. So now I'm going to join everything together, like that. Good. Okay, so then we are going to determine where the back side of the building be, yeah? The same, it will be similar to what we are having now, but a bit different. Okay, we are going to use the same approach. Let me switch to another color, which is used for creating arrays. 1 and 2. Yeah, it's good to work with just parts of building or another object that you are working with. So we are looking strictly for points where the arrays are going through the image surface here. Yeah, so here and there. Great. So then let's draw vertical lines without thinking much about the end of them. Yeah, like that. So there. Oops. Like that, right? So after that, we are going to build vanishing. We are going to build something that goes from the vanishing point. In this case, this one, left one, because it's somehow connected with this line. Yeah, this line is corresponding with this direction. It produces our point number 1. That's why we are going to use it. So, like that, right? The upper line will go like that. Please notice that here there is an intersection. It's very important. You can see that in this plate, the image surface cuts the wall, right? And that means that in this point, the size of the wall will be true size. So in other words, we are expecting this thing to be 120 mils. So let's measure it if that's true. So in my program, the sizes are in the right bottom corner. 120, exactly. Let me prove that graphically. So this point was 120 from the bottom. And you can see that horizontal line goes through these 2 points. Good. Let's leave this line there. Like that. Okay, so I'm going to change the color of the edge of the roof on the left of the building and of the bottom part of it, and also of the back side, like that. So pink will be our results. Okay, so we know where this point is. Yeah, let's talk about that one. So we have already found the penetration point. We have built the vertical line. Now we only need to determine the height of it. Yeah. So let's be again in green. We are building a line that goes from this point or that one in the plan, and it goes to our point that we are looking for. Yeah, that's why we are building it here. The same on the top, like that, and we can determine the size, yeah, by just creating 2 points here. Also, the same line will be participating in something like that. You can see that we got double intersections here in each case. Great. So let me create now a line like that. Another line can be created here at the bottom. Here I'm not going to create any lines because it will be a kind of this. Here we don't have any geometry. So then we need to determine where the peak of the roof is. Yeah. So 2 things can help. Let's go back to the green. So the peak there on the back side of the building will be somewhere on this line, right? So, but we don't know where, yeah. What can help? Two things actually. So we can pass another line through the point here, yeah, and look for its intersection with the back edge of the house here. And build a line like that, right? Vertical line. So this vertical line should be pink. In my case, of course, if you draw on paper, of course, it won't be pink. Okay, so we know where the peak is. Let's create two other lines like that. And another thing that can help here, or that can be a checker, is this. So oblique lines are going to, oblique parallel lines are going to intersect somewhere. And they are going to intersect since they are, let's say, belonging to the same surfaces as the bases, like that. I'm talking only about that this line and that line. If we project it to the floor, they would turn into this line, yeah. So that means that their vanishing point somehow should be relevant, somehow should be connected. Not directly, but let's see. So I'm going to extend, extend this line somewhere to the bottom. The same about this one. So I extend it and they are intersecting somewhere, yeah? And they are going to intersect on a projection of this point. So if this line is extended, they should somewhere be intersecting. So it's a good checker. If they do that, everything is fine. If they don't, please recheck what was wrong. These lines also be somewhere on the same line here, but on the opposite side, because they are, if you extend them, will be intersecting somewhere above the vanishing point. Here, right? Also, it's good to check these up. Great. They are somehow do that. That is a signal that we are on the right way. So let's continue. We need to create this extension and then the chimney as well. So the extension sits, this part of it sits in front of the, before the image surface, right? So it will be larger than the true size of the building. Okay, and somewhere it intersects with the surface. So here we are going to have the real size. Good. So the way is the same. We first need to create an array that goes through the desired point and touches the image surface. Let's do the same for this point. And the last point, which is there. So let's find intersection points. Like that. Then I suggest you creating vertical lines without thinking much about the length of them, like that. So here will be another line. Let's start it a bit below. And finally this one, right? So here we start. Good. So let's now figure out, maybe we can extend some existing lines and got the result. But the majority of the building has been already created. So, and that will be a good approach. So this part, this little line, is part of the wall, right, that we have already built. That means that if we only extend the line that goes to the vanishing point, we can find the not true, but the proper image of this line. So let me do that. Did not work. Okay, here will be the upper part, lower point. Then the second portion, this point, yeah, it's an extension on the top of the ridge of the roof at the bottom of the central line, yeah. So let's extend the lines. And find the points at the bottom, at the top. Good. And the final one here, yeah, the same approach. We just extend the green lines till the vertical one. And we got thus the points. Okay, now we can connect the lines, watching that they are going to the vanishing point number 2. Yeah, they are going there. So this line, since it's oblique, should go directly there, right? And it goes there. Great. This pair goes to this vanishing point. Yeah, or you can just connect them, it will be the same. Great, then let's determine where the division between the two stories is, yeah? So we know that one story equals the height of one story equals to 3 meters. So to do that properly, we should deal only with the lines that represent the true lengths. So we got now 2 lines like that. This one and that one, right? So in this case, let's work with the left one. Again, let me check up if it's 120. It is, yeah. In this case, I'm going to, so 1 meter. Sorry, we only need just to divide it into parts, right? Like that. Because we agreed that the building is double story, and the edge of the roof, the lateral edge of the roof, goes directly where the last story ends. Okay, in this case, we just divide it into 2 equal lines. Good, and then we do the following. We need to pass a line through this point till it goes to the edge here. Yeah, sorry, I have forgotten to build the resulting face of the building on the front, like that. Here we got a division. If we look at the building, we can see it here. It's not clear from the plan, actually. It can be read differently, but from the previous exercises, I understand that here we got something like that. So the back side is drawn. Let's show the wall. Good. Okay, let's go back to the division into 2 stories. This line will be drawn pink, like that. So now we should create another ray that goes from the vanishing point number 2 to this point, yeah? And it shows us the front edge of the balcony. Let's draw it in pink, like that. And also we need to show the deeper edge of the balcony that starts in this point. The technique will be the following. We are creating the ray, so a ray that goes from here to the vanishing point, and we are just watching the places of intersection of the surfaces. Let me show you what I mean. So on this stage we can isolate only the pink layer like that, right? Maybe it's too early. Let me go back. Just checking up. Okay, yeah, it was too early for that. Let me draw a line from this edge to that one. Then this line, if we extend it, will go there. Yeah, I won't do that. This line between these two things also being extended would touch the vanishing point. Like that. So now if we hide everything but the pink layer, we would see something like that, right? So this image unfortunately does not show us the visibilities, and it's something that we need to calculate now. So yeah, like that. Just checking up. Yeah, we are on the right way. Good. I don't know what it's for. Yeah, maybe it's 120 mils. Yeah, it is. Okay, let me delete that. So now we can talk about what is visible and what is not. Right? So let me switch to visibilities. And I would recommend you to always start with creating the outline, the silhouette of the building. It will be always visible. I'm talking about this. It will be always visible. Then we are going to go into the details slowly. So what else will be visible? Everything that belongs to the front of the building, to this thing. So in particular, this line that divides the building into 2 halves. Yeah. Then this edge of the balcony, which is in the final front, also will be visible. All the other parts will be partly visible, excepting only these little lines. They will be visible, of course. Then let me hide the pink layer now. What we see, yeah. Of course, we are going to see this part. It's the closest edge to the viewer. Yeah, looks natural. Somewhere here we are going to see the oblique lines. So let's focus on them. So they will be visible only here between this line and this, which is visible. The left part of the building will be showing only the surface. Other things will be hidden. So let me show you now. Yeah, looks fine. The symmetrical part of the roof will exist only between these two lines, like that. We can't see what is beyond this little surface, right? Okay, the second edge of the surface will be visible only till this edge of the balcony, like that. And the second part of it will be visible here, like that. The parallel edge will behave similarly, like that. Then let's add this little thing because it will be fully visible, like that. And let's add another lines. On this stage, it's obviously where they are going to be. So let me turn on the isolated visibility. So the facade of the building will be looking like that. And actually, the rest of the building will be looking like that. Yeah. Let's only add the hidden geometry. So this edge will be hidden, right? So I need to change the color, making it just a bit deeper. So now we can recognize it. Yeah, so it sits here. It's similar to this one, but now we can't see it. So line between the invisible line and the edge will be also invisible. The same for this one, so we can extend this till that. The same for these 2 points. We can join these 2 points together like that. So this part, this segment will be invisible as well, and this little thing also invisible, and this also. Good, that's it. All right, let's talk about the back side of the building. So in pink we built the wireframe, so not, of course, all the lines will be participating, but the upper part of the roof will be like that. So now we got the back facade of the building, all invisible, of course. The most distant part of the building from the viewer. These 2 points can be easily joined like that, right? Looks normal. Yeah. I have forgotten to build the chimney. Yeah. We'll say straight, it will be completely invisible, but let's build it. We need it for the task. So let's show the previous building, the previous plan, sorry, and let's just study what we got. It's a square, one side of which sits on the edge of the building, And also from the description, we know the height of it from the bottom. So let's start building this part completely similarly to what we did previously. So we are going to build 4 arrays by the number of points of the square that represent the chimney, like that, yeah. And let's place the points of penetration. Good. After that, not changing the approach, we are going to build vertical lines like that. Not thinking much about the height. Good. So 2 edges of the chimney are just sitting on the edge of the roof, yeah. So which points I'm talking about? These 2. Which lines, sorry, which edges? These 2 edges. So that means that we need to find the intersection with the perspective image of the roof top, yeah. So again, let's watch the lines. Oops. So this line intersects with the rooftop and this one, right? So this point goes here, this point goes here. Great. Then we need to also determine the height of it, yeah. Again, we need to work with the true sizes only where the object that we built intersects with the image surface. So either here or there. In this case, let me work with this line. It's easier because it's also sits, one point of it also sits on the rooftop. So 9.7 meters in case of 1 to 50 will be 194 mils. Yeah, 194 mils. So please don't mess these 2 lines. Now it's easy. We are working with the line that intersects with the image surface. Good, so let me place a point. And now let's illustrate the lines that goes to the vanishing point number 1 from here, from the true height of the chimney. So where this green line intersects with the vertical lines of the chimney, there we are going to create a couple of points showing the upper edge of the chimney, of the surface of it. So also we need to build up other 3. Good. So what can help us? This vanishing point can do that. Let's pass it through the points. Like that. Then I'm going just to clean up a bit. No. Okay, let's just continue. So thus we can understand where these bottom lines that intersect with the surface of the roofs are, yeah. So let's only build up the points. Yeah. So we got the upper edge, we got the edge that sits on the rooftop, and sorry, I've built wrong lines, not like that. I should have used the lower row of them. All right, so we are looking for intersection with the blue lines. Like that. So these 2 points should be sitting on the line that goes to the vanishing point number 1. Yeah, they do. Okay. So we need to build up this surface, this one. Let's create another couple of lines that go through the first row of the vertices, like that. And we again looking for intersection of these lines with the lines that shows us vertical edges of the chimney, yeah, like that. And these 2 lines, these 2 points, sorry, should be sitting again on the line that goes through the vanishing point, and they do. Great. Let's now build up the lines. I'm going to hide the other layers like that, so we can read the drawing properly. Like that. So this one is parallel to this, yeah? I mean, in the drawing, in the plan. So the same for this one. I'm going to draw vertical lines. Right? So looks quite natural. Yeah. Okay, yeah, looks natural. Good. Let me just check up. Right, so let's go back to the visibilities. The chimney will be completely invisible because it sits inside inside the outline of the silhouette and beyond the surfaces, yeah, the facade surfaces. So will be completely invisible. So let's see what I'm talking about. Right, something like that. And now we are going to talk about the shadows. So here in the initial drawing, in the given of the task, we got these 2 points and a line that connects them. So these 2 points are the, let's say, vanishing point of the light, and also another vanishing point of the light. So let's see how these things work. So we only need to create another layer for lighting. Let's say we got not a building but only a line, this edge, right? So if we needed to create its shadow, we would do the following. We would find the upper point of the line and connect it by means of a line with this vanishing point of the light. Yeah. To be able to find where it intersects with the ground, we would create a line that goes through the base of the line here, yeah, and it goes to the horizon, to the vanishing point of the light there. Good. Where these two lines are intersecting, we would find the end of the shadow. So the shadow itself would be only like that. Knowing that concept, let's build up the shadows. And we are going to start with the shadow that falls onto the ground. We have already found this point. We need to find this one, and one of these, and we are able to create a polygon that represents this shadow. So let's pick up the top of the roof. We need to find where the bottom of it is here. We are going to connect it to the vanishing point on the horizon. And where these two things are intersecting, there we are going to find another vertex. Good. Then this point comes to force. The way is the same. So we can find the same things for the back facade. Let's start here. So this line, if we want to find the shadow of this line, right? It goes somewhere here, yeah? Let's see where this line is. Ah, yeah, to this point. And they will be on the line that goes to the vanishing point number 1. Like that. Why? Because this line and its shadow will be parallel, yeah? And that's why they can use the same mutual point. Good. All right, then let's create another pair. This and that. Oops. Yeah. So here I need to use snapping. So let's see what edge we can create. So it goes here, right? So it's the upper part of the building. This line produces this shadow. And finally this edge. Let's see what this line intersects with this point. Okay, I'm just going to trim this up to this part. Okay, these 2 points actually will be connected because this little thing represent this edge, the shadow that belongs to this edge. Good. So let's create now this fallen shadow. So it will start outside the building there. Then it goes here. So in this line, that it slides to the top like that. And on the ground it will be this tiny thing. Then this edge actually also can be built. It's here, but it's within the shape of this shadow, so there is no need to do that. So from here it goes directly to this point, but we don't see it because the wall of the building just eats it. So let's go here and then we go to the initial point. And if we turn off the light layer, we would see something like that. Little shadow on the back side of the image. Okay, but actually we are going to build shadows that are here, yeah, projected shadow, that are caught by the surfaces of the building. Good. So also we need to check if the chimney participate, and actually it will. Yeah, it will participate in the fallen shadow. So let me turn on the light layer, and to build up the chimney we need to build its projection to the ground, right? So we need to go back to the pink layer. So these two lines can be extended till the base midline, yeah, here. Let's pass a couple of vanishing lines through these points. One like that. Another one will go like that. Actually it goes to this point, yeah. This goes to the same line, right? So this line goes like that. It then slides along the wall and goes back. We can create another vertical line that sits like that. Okay, so these two lines being extended just hit these two lines. Let's do that. The first one, the second one. And we can connect this shape. Just checking up, let's create another line that goes through these points. They should be on the same line. And also, moreover, they should be on the same line with this one, because we need to build it up. So the line goes like that, then it turns to the ground and goes here. So let's see if it's true or not. This one is true because it goes along the top edge of the roof, bends, turns into vertical, goes here, and here it is. This part we are going to turn, we are going to extend this line till the edge of the roof here. Then it bends over the wall and goes to the same line. Yeah, great. So everything is fine. Good. Then we need to pass a couple of lines through this new shape. Actually, let's take this rectangle, distorted rectangle, let's name it so, and send it to the visibility as temporary. Just temporary. I just want to turn off this mess of lines. So here we got this little thing, and we can work more conveniently with it, with the shadow. Okay. So going back to the light layer, let's pick up first this entity, this edge. So it goes like that there, and we need to pick up the corresponding point in the plane and send it to the vanishing point, and look where these two things are intersecting. Here. Good. So let's pick up this one next. Corresponding point on the plane. Great. These 2 points, once connected by a line, should go to the vanishing point number 1. They do. I'm not going to build up the whole line like that. We have found only the upper part of the shadow created by this surface. Let's add the others, and we can understand how it goes to the main shape of the shadow. So I suggest us picking up this one and doing the same procedures. So where the point is, here, okay. So you can see that the shadow of the chimney becomes more and more protruded and visible. Okay, now we got a pair of points that can be connected with a line that theoretically would go to the vanishing point number 1. Good. Then, so we got this, just an edge. We need to build up these 2 points and these 2 points. So this point, we are looking for intersection of this line with the line that we have already built before, this one. So here it is. Great. The same for another point there. So we are looking for its intersection with already made line. Here, yeah. And they are sitting on the edge of the main shadow, because this part shows us the top edge of the roof here. Good. Okay, another couple of points, this and that, are intersecting. Let me change the color because it's really easy to mess up the things. And the last one, so this one, it goes into intersection with this line. Okay, these two last points should be also on the line that goes to the vanishing point number 1. Let's now try to connect all this stuff. So these two lines show us the edges of the upper surface of the chimney, and we don't know where these two lines are, but we can find it between intersection between these 2 points. They will be oblique like that. Let's create a line here, the same here, and this little line forms the shape of the shadow. So if this one will be invisible because it's within the shadow of the chimney, this edge will be also forming the shape of the shadow, so everything that is within it won't be visible. But this line, this little line, and this one are forming the shape of the main shadow. So let me switch to this layer, and we are going to add to the main shadow this little piece like that. Then it bends to the left and goes like that, and the rest of the shadow we don't see because it's beyond the building. So let's see what we got. Yeah, this one. Yeah, looks quite natural. Let's turn on the projection layer. Yeah, will be like that. Okay, so let's now mirror these two pieces together. Good. And it's time now to talk about the projected shadows and self shadows as well. So let me turn on the layer. For example, this ray, yeah, it goes to the vanishing point of the light there, but on its way it intersects with another entity that belongs to the floor surface. So it belongs to the floor surface as well. So where these two lines are intersecting, there we are going to create a point and raise a line like that, vertical line. So it will be a footprint of this edge, of the shadow of this edge. So on its way, it goes with intersection with interferation with this surface and just puts a shadow onto it. We only need to understand where the top part of it will be, yeah? But it's quite easy because we only need to find where this ray goes. Yeah, let's intersect this ray and this footprint of the shadow. So we got the point. So from this point, the shadow will go to this one directly, because this point is lit. Here shadow can't exist. And there are no blocks on the way of light, if we talk about the edge of the surface here. So it goes like that. Here I got a little discrepancy. Please forgive me. So I need to approximate. Okay, let it be like that. Let it be like that, yeah. So that's it, yeah, about this part. The same situation is going to happen there. And let's figure out what to do. So the shadow that is created by this edge goes, it slides, it covered the ground, but on its way it intersects with this edge and with the surface that is an extrusion of this edge. And of course it will create a vertical line, because the edge that creates this line is also vertical. Yeah, it goes like that, it blocks by the surface, and we see the footprint of this shadow there. Okay, but let's see if it's possible to find the point of intersection of the line that goes from this point and this line. Of course it's possible, but where it's going to be? Let's find the things. For this reason I'm going to make this line longer. Then I'm going to select them and intersect. So here is the point. So in this point, this footprint would start bending, as we saw here, if the surface would have been taller, right? But it's shorter than this part. So the light which exists here just bends over the surface and gradually goes to the highest point. So from this intersection we can build a line that goes to this point. Great. So let's talk now about these two things. We are looking at the bottom parts of them, yeah? So here a light doesn't exist. Here we got self-shadowing. But they somehow will create something like that, little things there, right? So let me see what I did before. So we need to, let me look up what I did. Yeah, the same, actually the same. obviously. So we need to turn off that one. We only need to find where this thing is by just sending this to there, like that. And here, where the two lines are intersecting, we got the point of bending, right? If there were not these two things, or in particular this, because we are talking about this one, the shadow of this edge won't anyhow be muted, yeah? So it would go like that directly there, but occasionally this little thing appears, yeah? And this point can be determined on this footprint of the shadow, of course, yeah? So it's here. From this point to this point, we need to create just a gradual line. But this point is completely lit, yeah? And shadow doesn't exist right in this point. Here, if we trace this little point, we would derive this little triangle, and more and more and more till this point. Okay, let's do the same for this piece. So this is a footprint of this edge onto this surface. So let's first connect these 2 points together. And we got a point of bending. Oops. Good. And actually that's it. We have created the wireframe, the skeleton of the shadows. Let's now just fill up this skeleton with the hedge and show where the shadow is. So, not here, sorry. I would not like to divide self shadows and projected shadows because they turn into something mutual, and I just don't see any sense of dividing them. Okay. So from here to here, I got this little discrepancy. Then shadow goes like that, here, 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 then it goes vertically downwards, it slides to this corner and goes to the initial point. On this part it goes like that. Here we got self shadow. That's why we got this peak. This one is projected. One goes vertically, then slides along the floor and goes back to the initial point. So let's turn off this auxiliary layer and we see the shadows. Let's turn off another things. Actually, when you draw visibilities, I think it's not a thing to just draw up the horizon which will be visible, because it makes your image just more complete. Without this horizon line, it's just floating in space. We don't understand the geometry. Yeah. And let's just fill up these shadows with something so we can say that they are shadows. It's too harsh, yeah. Let's pick up something different. Okay, looks fine. So that's it. If you got any questions, please let me know. And I wish you good luck with finalization of this task.